rate, and then this is concentration. So I said second order reaction is obtained when the rate of reaction depends on the scale of the concentration of the reactant. We obtain second order reaction. And the last one I want to talk about here is the zero order. Now we can also have what we call zero order reaction. And this is obtained when the rate of reaction is independent on the power of the reactant or on the concentration of the reactant. That is, the reaction can proceed without the input or the concentration independent of the concentration of the reactant. So in this case, what we have, you can see this in the composition of hydrogen peroxide, where we have hydrogen iodide, where we have H2 plus I2. Now in this case, our rate will give us K into H raised to power 0. So here we have zero order reaction. We have zero order reaction. And then the graph will show constant. That is constant. The graph is going to be something of this nature. We have concentration and we have rate. So since what we are saying here is that the rate will not depend on the concentration of the reactant. So we are going to have a graph of this relation. So that is the three types of order of reaction that I want to talk about. I said the first order of reaction, the first order of reaction, we have the first one to be first order of reaction. And I said in first order of reaction, I have the rate depending on the concentration of the reactant. While in second order reaction, I have the rate of reaction depending on the square of the reactant in respect to A. Then I said in zero order, then the rate of reaction is independent on the concentration of the reactant. Now we'll quickly look at how to apply this mathematically. So I'll put example on the board and then we solve. Then from there you can practice on your own. So let's look at this exercise. If we have a reaction S2O8 plus giving now from this the following from that equation reaction. Now from this we have the following data. Here we have everything is in mole per liter. So if the first one we have 0.036, 0.072, 0.036, 0.060, and then the rate for the first one is 1.5 times 10 to the power minus 5, 2.9 times 10 to the power minus 5, and then we have 2.9 times 10 to the power minus 5. Now from this data obtained, we have to calculate the following. One, the order of reaction with respect to each reactant. Then B, we will calculate the rate, constant K. Then C, we will calculate the reaction rate. Reaction rate when each reactant concentration is 0.20 molar. So if we have this question, and from this question we can apply the order of reaction, and then we will be able to solve them using the method.